Question number 9 is a fairly short algebra calculus question. And so part A, they want you to expand the expression, and expand the expression basically means multiply, so you don't have any parentheses. So I just have to multiply the x, and I get 2x to the 4th minus x. 2 marks. 1 mark, 2 marks. Then they want you to differentiate this, but there's a reason why you just wrote that, because you can't differentiate this unless you've expanded it and multiplied it out. So the derivative of this is the same as the derivative of that. And we have 8x cubed, 4 times 2, reduced by 1, minus, and x becomes 1. So there is the derivative. And then they want you to find the coordinate of the local minimum. So if you want to do some work, show me some work. The local minimum should be when the derivative equals 0. And so I have 1/8, and the cube root of 1/8, I happen to know, is 1/2. Find this local minimum. You know you can graph this function and then use your calculator to find the graph. I would, just to impress the examiner, write down this equation so that they are aware that you know the derivatives that equal to 0 is where you find a minimum. But you can go straight from here onto your calculator, graph it, and find the local minimum. So the first way to use your calculator to solve this question would be to go under Math and use the solver. And again, you will need to set the equation equal to 0. And once you've done that, you just simply need to type in the equation you want to solve. And then alpha enter is to solve, putting it over where x is, and you can see we get that answer of 0.5. So that will be the first way of solving the equation. The second way is, yes, making the graph and finding the minimum value once we've graphed it, and you're graphing the original equation. So 2x to the 4th minus x, and under the standard window we can still see where the graph has a minimum, and so we simply need to run through the steps to calculate the minimum. Important thing to remember or just check is that you will move the cursor slightly to the left of where the minimum is, to the right, and then you can move the cursor back where you think the minimum is to calculate. It doesn't come out to be perfect, 0.5 like we had with the solver, but you can see in rounding that it comes out to be the same answer.